B10, we see an escalator. They step on it at point A, and they step off at point B. We know it's 30 meters long, makes an angle of 40 degrees with the horizontal. At full capacity, 48 people go from A to B every minute. So 48 persons per minute can do that. We're asked what the potential energy gained by a person, by one person, with 700 newtons is moving from A to B. Well, the change in potential energy is mg delta z. And mg, that force, that mass times gravity, is the weight. So we know that's 700. So we are simply tasked with finding out what the change in z is. So we have a right triangle with our hypotenuse, our opposite side, our adjacent side, and this is going to be delta z. This, of course, would be delta x, but we don't need it. So this involves looking for the opposite side when we know the hypotenuse. So the sine of 40 degrees equals delta z over 30, and therefore delta z equals 30 sine 40. Using our calculator, we have 30 times the sine of 40, which is 19.283. That's delta z. Now we put that up here, we want to make sure it makes sense. 19.283. So we have 30 meters, so delta z must be less than 30, and it is. So now we have 700 times 19.283. And that change in potential energy then will be that number, our answer, times 700. 13,498.5. That's the change in potential energy. Let's see, our 7.0 has two significant digits, so we can only report those two. And so that 4 would mean that stays the same. So we are looking at 13 kilojoules. So 13,498, 13 kilojoules, or 1.3 times 10 to the 4th joules. Either one of those is a fine answer for this question. Moving on to the next part. The energy supplied by the escalator to people every minute when the escalator is working at full capacity. Well, that is just simply going to be, we know how much work is done by 1. Now we want to know if it's the 48. So we're going to multiply that by 48. Our answer, we'll use the unrounded answer. So we have 13,498.5 joules per person times 48 persons per minute. And that means that we have, we'll multiply that out. So that answer times 48 is 647,929. Is 647,929 joules. So so we want the energy for every minute. So it's 647,929. And again, we can only report two significant digits. So that would be 6.5 times 10 to the 5 times 10 to the 5th joules is the energy supplied. So an assumption we made to obtain this answer. There are several assumptions we made. The first one is that the average weight of all riders is 700 newtons. That's the first assumption. We found it for one person who was 700 and then projected it to 48 as if they were 700. The next thing is not so subtle or simple in that the work being done by this escalator is about carrying people from the bottom to the top. And the work that is done goes into changing potential energy. Now, let's suppose the person is standing here, they're leaned over the escalator, and they step on it. They had 0 velocity before, but the escalator is also accelerating them. So there's some work that goes into not only raising it up, but changing the kinetic energy here. So what that means is that it assumes that the kinetic energy of the riders remains constant before, during, and after the escalator ride. That, of course, requires that the velocity is constant while on there, but also requires that the escalator is not doing anything to change the kinetic energy. And remember, the work energy theorem is about the change in kinetic energy being equal to the work done. Well, if there's a change in velocity, that means there's a change in kinetic energy and there must have been work done, and so the escalator is doing work also to change the velocity. Lastly, we have the escalator is driven by a motor that has an efficiency of 70%.